Welcome to Bits, Bytes, and the Binary Numbering System, the language of computing. I'm Jason Boyer, Information Systems faculty at Reedley College. The purpose of this lesson is to help students better understand the binary number system. Upon completion of this lesson, students will be able to demonstrate understanding of the binary number system by converting decimal numbers to 8-bit binary numbers and binary numbers up to 8 bits in length to decimal. The decimal numbering system is based on the number 10. We have 10 fingers and 10 toes, so it stands to reason that most human number systems are based on the number 10. Each column in a number has a value with a certain place value. The base, 10, is increased by the power indicated by the exponent. Each column from right to left increases by a power of 10, starting with 10 to the 0, or 1. And as the number moves left, it multiplies by the base in each column. For example, the number 1,234 can be expressed as 1,000 plus 200 plus 30 plus 4. Or we can say 1 times 1,000 plus 2 times 100 plus 3 times 10 plus 4 times 1. Or we can say 1 times 10 to the third plus 2 times 10 to the second plus 3 times 10 to the first plus 4 times 10 to the 0. Any one of those things or any one of those notations will express the number 1,234. So for the number 128, we can break it down by placing a 1 in the hundreds column, and we multiply that by 100. So that's 100 plus 2 times 10, which is 20, plus 8 times 1, which is 8. 100 plus 20 plus 8 is equivalent to 128. We can annotate 4,096 the same way. We can do the same thing for 1,048,576, and we can also do that for 83,611,308. The binary number system is based on the number 2. Computers understand just 2 digits, 1 and 0. The smallest unit is known as a bit or a binary digit. A group of 8 bits is known as a byte. And it's based on switches being on, 1, or off, 0. Boolean logic, on which digital computing is based, uses true and false for 1 and 0. Each column in the number has a value with place value based on the number 2. The base, 2, is increased by the power indicated by the exponent. Each column from right to left increases by a power of 2, starting with 2 to the 0, or 1. And the value increases by multiplying the base 2 as each column moves left. So for example, we start with 1, then it moves to 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, etc. As an example, we can express the binary number 1010 base 2 as 1 times 2 to the third power plus 0 times 2 to the second power plus 1 times 2 to the first power plus 0 times 2 to the 0 power, or 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1, or 8 plus 0 plus 2 plus 0, which equals 10. Now don't worry, I'm going to go over this again. I'm going to show you a simpler way to do this. Let's look at binary number system conversions. Use what you know about place values to convert from binary to decimal. Each digit, just like in the base 10 system, has a place value. It's easier though, because either the number contains a value, 1, or it does not, 0. And when you're doing this, always begin with the least significant digit on the right and fill in to the left, just like you would with a decimal number. So the process for converting from binary to decimal, every time we're going to add. Remember, binary to decimal, add. Binary to decimal, add. I don't have a nifty mnemonic device for you. Just remember, when you convert from binary to decimal, you add. Begin with a table with place value headings, and for our purposes, we'll always assume 8 bits. Fill in the numbers from right to left, and then beginning at the left, multiply the digit by its place value. Finally, add them up. It's that simple. Let's take a look. Okay, so on this page, I've created a chart. It has 9 columns. The first 8 columns are the powers of 2, where you go from 2 to the 0 on the right to 2 to the 7th on the left. And below that, I've written the decimal values for those numbers, beginning with 1 as the value of 2 to the 0, going all the way up to 128 for 2 to the 7th. And if you see the pattern there, all we do is multiply the number that we're on by 2 to get the next number. So we start with 2 to the 0, which is 1. We multiply that by 2, it gives us 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th, 32. And 64 and 128. Very simple pattern. So in this case, look at the directions below. I've given you these directions down below. And the first thing we're going to do is begin with a table with place value headings, assume 8 bits, which we've done. And then we're going to fill in the numbers from right to left, which we've also done. So we have 1, 0, 1, 0. Beginning at the left, we're going to multiply the digit by its place value, and we're going to start with that 2 to the 3rd. So I have a 1 in that column, so it's 1 times 8, which is 8, plus 0 times 4, which is 0, plus 1 times 2, which is 2, plus 0 times 1, which is 0. 8 plus 0 plus 2 plus 0 gives me the decimal number 10. Let's look at another number. This one's a little more difficult. It's a little longer. Really not that much more difficult, though. This binary number is 10101000, base 2. And we're going to convert that to a decimal number. So all I have to do is start at the left and begin by multiplying the digit by its place value. 1 times 128 is 128. 0 times 64 is 0. 1 times 32 is 32. 0 times 16 is 0. 1 times 8 is 8. 0 times 4 is 0. 0 times 2 is 0. And 0 times 1 is 0. Now when I add those all up, I'm going to add 128 plus 32, which gives me 160, plus 0 plus 8, that's 168, plus 0 plus 0 plus 0, it's a total of 168. Simple, right? Let's look at converting numbers the other way. So decimal to binary conversion is the opposite of binary to decimal. Well, the opposite of addition is subtraction, so instead of adding, we're going to subtract, and I'll show you how that works. It's just as simple. Begin with the decimal number and start with the largest place value, 2 to the 7th, or 128. Then test to see if you can subtract the place value. You cannot go below 0. If you can subtract that value, you'll place a 1 in the column, else you'll place a 0 there. Here are the rules. Decimal to binary conversions, remember we subtract. Begin with a table with the place value headings and assume 8 bits. And starting from the leftmost digit in the table, attempt to subtract the value of that digit. If you can subtract it without a negative result, place a 1 in that column. If not, place a 0. Finally, continue subtracting until you have reached the 2 to the 0 column or the 1 column. Now I will throw a little caution in here. You should never see this from me, but if you have a number that's greater, a decimal number that's greater than 255, you will need more bits. So you simply continue your table on. We're not going to do that for anything that you do in IS-15, so don't worry about it. Okay, so here are the steps. We have the number 15. We're going to convert the number 15 to binary or base 2. So all the way to the right, I've already written the equivalent decimal number, and I've made a little note there that says the binary equivalent is, and then I put a bunch of question marks. We'll figure that out at the end, but I'm also going to keep that note in there so you can see what's going on. You can see the number as we progress. So in the first column, I have the number 15. Can I subtract 128 from 15? And the answer is no. So I've placed a 0 in that column. Can I subtract 64 from 15? The answer is no. Again, another 0. Can I subtract 32 from 15? No. Can I subtract 16 from 15? No. However, can I subtract 8 from 15? Absolutely. So I'm going to place a 1 there. And can I subtract 4 from what's left? Well, 8 minus 15 minus 8 rather is 7. Can I subtract 4 from 7? Absolutely. 7 minus 4 is 3. Can I subtract 2 from 3? Absolutely. And can I subtract 1? That's what's left over. That gives me 0. So my final binary equivalent number is 00001111. Now, just like in a decimal number, for the purposes of our tests and our assignments, you may omit the leading zeros on that binary number. You can also leave them in there. It's your preference. For our examples here, I'm going to leave them in. But I did annotate on here that you could write 1111 as the final answer. Okay, now let's take another look. We're going to use a little bit bigger decimal number. We're going to use the number 222. Let's convert that to binary. So we start off with the number 222. I've written that over in the right column where it says equivalent decimal number. And I'm beginning with a table with the place value headings, the same one we've been working with. So first question I ask, can I subtract 128 from 222? Well, 222 minus 128 gives me positive 94. I'm going to place a 1 in that column. In the next column, 64. Can I subtract 64 from 94? Remember, 94 is what I had left over. So 94 minus 64 is 30. Absolutely, I can subtract that. So I'm going to subtract 1 here. Now, I have 30 left over. And with 30 left over, can I subtract 32? The answer is no. So I'm going to place a 0 there. Now, I can certainly subtract 16 from 30, and that leaves me with 14. So I'm good there. I can put a 1. And can I subtract 8 from 14? You bet. That leaves me with 6. So I'm going to put 1 there. Now, can I subtract 4 from 6? Yep. Place a 1 there. And I have 2 left over, and I can subtract 2. That leaves me with 0. And so I know I can't subtract 1 from 0, so I'm going to put a 0 there. And my final binary equivalent number is 1101, 1110. Simple? Okay, some tips for completing the assignment. Whether you complete this assignment electronically or whether you decide to do this on paper, if you're doing this online, I will give you the option to either submit a Word, a PDF, or something similar to Canvas, or you can take a picture of your assignment if you decide to handwrite it. I will warn you, it has to be legible, it has to be upright. If it's turned to the side or if it's upside down, I will not accept it. But I do want those to be upright and legible. If you're using your phone, make sure it's absolutely clear. Use an additional sheet of paper or a table in Word or Excel to help you. I want to see your work. I don't want to see just the answers. I want to see the work done with it. That way, if you're having trouble, I can help you. Start by creating a table similar to this one. And then remember the rules. For binary to decimal conversions, you add, fill in the numbers from right to left. Beginning at the left, multiply the digit by its place value, and then add up those totals. For decimal to binary, you subtract. Starting from the leftmost digit in the table, attempt to subtract the value of that digit. If you can subtract it without a negative result, place a 1 in that column. If not, place a 0. Remember, every time you subtract a number, you subtract from that total, so your total will get less and less. And then continue subtracting until you have reached the 2 to the 0 power or the 1 column. You may also omit the leading zeros. For example, 0, 0, 0, 0, 0, 1, 1, 1 becomes 1, 1, 1. And that's it.